So as we just saw, we figured out a lot of information with this little black figure at the right just by knowing what the leading coefficient is and actually finding what the vertex is. It told us right away that we're going to get two solutions, two unique solutions to this function represented by this equation. But we're not sure if they're going to be integral, and the way we're not sure is because this actually is not factorable. There aren't two factors that multiply to give you 6 that's going to add to give you 6. There aren't two factors that make that happen. And so what we need to do is we need to use our calculator, use the tools available to us, use our calculator to figure out what these roots could possibly be. Because they're definitely not going to be integral roots because we can't factor them. Integral just is telling you that they're not negative or positive whole numbers. And so what we're going to do is we're going to plug in what the equation is. So we're going to click on y equals, and then we're going to put in x squared plus 6x plus 6, and then we're going to click graph. And so just as we thought, actually, this parabola has a vertex at -3, -3, and it crosses the graph at 2 places, but notice each of these tick marks is represented by 1. And so if each of these tick marks represents 1, clearly this graph crosses somewhere between -1 and -2, and somewhere between -3 and the end of the graph. And so what I'm going to do actually is I'm going to size my window so I have a better view of what's happening to this graph. So I'm going to click Window, and since my graph ends at -4 it's my x value, the x minimum for the window is -4.7, I'm actually going to change that to a smaller number, or a larger negative number, which is really what I'm saying. And I'm going to put that out at -7, just so I have a better idea of what I'm looking at. And so by doing that and clicking graph, I've now shifted the window over so I can actually see where the other x-intercept for this graph, where the other solution, where the other zero, where the other root. Remember, all 4 of those names mean the same thing when we're solving this equation and then looking at its function. So again, we can see that between -1 and -2, the graph crosses the x-axis, so that's going to be one unique root. And between -4 and -5, the graph also crosses the x-axis. So we need to check to see what these two things are. So there are a number of ways to do this. You can approximate it by tracing the graph, but we're going to use the calculate function. So if we look above the trace, it's a blue CALC word, and that's basically there for calculate. And to get to the blue, we need to click the button that also is blue. And so we're going to click second, and we'll click the button trace, and that gives us the calculate menu. And so what we're looking for is we're looking for the 0 of the function. And since we're looking for the 0 of the function, we're going to click number 2, or press number 2. And then it's going to ask us some questions. So in order to figure out the 0 of the function, you need a left bound, what's called a left boundary. So you're telling the calculator where to look, because the calculator needs to narrow down where it's going to look for where this function crosses the x-axis. So you need to say what points on this graph would be to the left of where you think the root is, where you think the x-intercept is. So you're going to click left until you get right below or right above, depending on right below or right above, depending on what you're looking at. You're going to click left until you get to the left of one of your roots. Then you're going to click enter, and that's going to be the left boundary that the calculator is going to look for this x-intercept. Then you're going to click over to the right until you get to where you think the right of this actual root is, where this actual x-intercept is. You're going to click enter. And then the calculator asks you to guess. So then you're going to try to go somewhere in between where you just picked, and you're going to click guess. And when you do that, what the calculator does is it zeroes in and keeps looking and keeps looking and keeps looking to see exactly where, or approximately where, this function crosses the x-axis. And since in the problem it says find the 0 or find the solution by graphing and figure it out if it's non-integral to the nearest tenth, we see that the x value, or the x-intercept, is minus 1.26. So we're going to round that to minus 1.3, and that would be one of our two unique solutions. So now we have to repeat this process to figure out what our other unique solution would be. So we're going to, again, click second calc, or second trace. To get to the calculate menu, we're going to click 2 for 0. And then, okay, we're going to press left until we get to the left of our other intercept. And then we're going to hit enter for the left boundary. We're going to go to the right of our intercept. Again, left and right are x values. Then we're going to hit enter for our other boundary. And then we're going to just click somewhere that we think is around what it is, to guess, to give the calculator some help. And so the calculator now looks at and sees that we have the other 0 at negative 4.73. Again, since we're rounding to the nearest tenth, that would be negative 4.7. So we get our two zeros by using our tools, using the electronic tools, using the calculator, to figure out where this graph, this function, crosses the x-axis. One place is at negative 4.7, because they said to round, and the other place is at negative 1.3, because they said to round.